Well, you remember that total eclipse of the sun a few weeks ago? I was walking in the wholesale flower district that day, and I passed by this place where this old Chinese man, he sometimes sells me weird and exotic cuttings, 'cause he knows strange plants are my hobby. He had nothing unusual there that day. Nope. And I was about to, walk on.
Well, hello everybody. So, what we're going to discuss now is called conditional probability. This is chapter 10 of your textbook. And the hardest thing I think for students in conditional probability is just stopping for a moment when you're reading a question and thinking about what it says. So we'll discuss that part of it at the end. But for now, I just want to get right into it and make sure we understand what is meant by conditional probability. Okay, so let's go to the board. There we go. All right, so here, what we're looking at is a Venn diagram. I've given an example here where we have A and B as two events. You can see here that the probability of A is 50%, the probability of B is 40%. The probability of A intersect B is given as 30%, which means the probability of A union B is 60%. And there's lots of other quick calculations we could do here. So what we're interested in answering is two questions and seeing how different they are. What's the chance A and B happen? What's the chance they both happen? This, I am hoping you both recognize immediately, asks what's the probability of A intersect B? What's the probability of A intersect B? And that in this case would be a very easy 0.3. But the next question is very different. What's the chance that A will happen if we know that B will happen? So if I know that my answer is going to be in here, I know that the outcome of the experiment will be in B. What's the chance that A will happen? Well, before we learn to write the notation, I hope that everyone sees that it's 0.3, but out of a total of 0.4. Not this 0.4, but the fact that they end up to 0.4, which is 0.75. So this is called conditional probability. And it is noted as the probability of the question line the given. So let me just make a little space here by getting rid of my example. Let's get rid of that part too. I'm just going to move this up here, this here. I use Paint because I think it's pretty easy to manipulate. So in our example that we just did, we asked for the probability that A will happen given that B happens. So the big thing here is the question says, what's the chances of A? So A is the question. Don't mix up these two. Don't write B given A. It's a very different thing if we do B given A. Now let me just try to... Oh, I can't do that part. And then I'm going to put that back the way it was and just cut that back. I want my diagram to go back here. And we know that 0.4 is there. Actually, I'll just quickly write it back there. Boom, 0.4. There we go. Okay, so here, what is the formula that we would use for conditional probability? Well, if you remember, we said it was 0.3 divided by 0.4. Let's think about what that 0.3 was. That 0.3 was the probability of A intersect B. That's this area right here, right? This area right here was our value. Let me just fix that a little. I'm just going to make it easier for me. I'm going to do a 0 with a tiny little gap there so that when I paint this, it fills. Oh, there you go. Okay, so 0.3. Now, what did we divide that by? We divided that 0.3 by this two numbers here, which is the probability of B. So if we shrink that back, this happens to be called the conditional probability formula. Okay? Now, I do want you to note here, what if the question was the other way around? What if I asked, what's the probability of B given A? So to do the probability of B given A, what do I know is going to happen? I know A is going to happen. So because I know A is going to happen, do you see that what I want is, I'm asking B is this number, so 0.3 divided by the total here, which is 0.5. And it really is the same formula, it's just that the letters are reversed. So this is P of B intersect A divided by the probability of A. And so I want you to see that the one on the bottom is always the given. And the other thing I want you to see is these two pieces, the probability of A union B and the probability of B union A, those actually are the same thing. So where B and A happens is the same as where A and B happens. We're just semantically in different directions. But the formula is very careful to say it's the given that goes on the bottom of the formula. It's the given that goes on the bottom of the formula. So I think it's time to look at an example that's a slightly bit larger. And what we're going to do is not just place two circles on our diagram, but we're going to place 3 on our diagram. So each one of these is a zone. And we can come in here and place probabilities like 0.1, 0.05, 0.03, 0.02, 0.1, 0.2, and even 0.3. This tells me 3, 4, 5, 6, 7, 8. This number out here must be 0.2. And then we just need to label them. Let's call this A, B, and obviously C. And then we can look at what questions we could do from this Venn diagram. So we could ask, what's the probability of A? And we see that A is 1, 2, 3, 4 zones. So we're going to just simply add those up. 0.1 plus 0.05 plus 0.02 plus 0.03. And it turns out that A has a chance of 20%. Okay? Now, when you're doing a Venn diagram question, we probably don't need to show all that much detail. We could very easily probably have just written the 0.2 there. It's very straightforward. The probability of B, well, let's fix our fill and then pick a new color. B is these 4 zones. So 0.2 and 0.1 is 0.3, and 5 and 3 is 8, so this is 0.38. And the probability of C, and again, let me undo my pink here. You've seen that. But the probability of C, let's do brown, is these four numbers. So this is 0.3 and 0.1 is 0.4, and those add up to 0.5, so 0.45. So by having all this different areas, we are allowed to, or very easily able to, calculate what we want. Now, let's go back to our diagram. What else could we look at here? Oh, I can't write in white. We could look at, for example, the probability of A intersect B here. And we have to observe that in this case, A intersect B is all areas in both A and B, which in this case would be 0.08. We also could, for example, ask for the triple A intersect B intersect C. And that would be just this green area here, which would be 0.03. You see, that's the one area that's in A, in B, and in C. Personally, I think Venn diagrams make it so much easier than trying to struggle with a whole bunch of math formulas on this one. But this also helps us look at conditional formulas a little easier. So let me white back everything to white. And pick a new color. So here, probability of C, line A. The word line is read as the word given. So C given A. So when you hear that, C given A, what's given? A. C given A. C is the question, A is the given. So A is the new universe. So what is the probability of C in this universe? It's 0.05 divided by A is 0.20. I think that blue's good for coloring. I think it's too light to write on, so I'm going to switch to black. So our C, these are our two numbers that are in C. So that is 0.05. And A is this whole circle. We've already worked that out to be 0.2. And 0.05 divided by 0.2 is 25%. So in this example, if I said to you, what's the probability of being in C knowing that we're going to be in A, it's 25%. Now you might ask, like, wow, like, where does this come up in real life? Well, what's the probability of getting cancer if you're a smoker? What's the probability of getting lung cancer if you've already had pancreatic cancer? What's the probability of getting asthma if you've had COVID? Those are all questions that we ask daily in medical science that is conditional probability. We break our population into those that have had the given and those that have not. So I might say that there's a 20% chance in the population of having cancer, but then I might come back and say, however, if you're a smoker, that chance increases to 40%, right? And so we look at that conditional probability as being very relevant. And I mentioned in an earlier video in this course about my mother being very low birth weight when she was born. So I'm very interested in the probability of needing a knee replacement if you were under 3 pounds when you were born. The probability of requiring hip replacement or bionic implants or osteoporosis occurring if you were under 3 pounds born or under 2.5 pounds born. So those are all conditional probability questions. Now let me just back up a tiny bit here so I can get rid of a little line here. And let me fill these back to white. And I'll just do one more example for us. One that's a little bit more complicated. All right. What's the probability of being in C given that you are in A union B? So again, there are formulas. From a formula point of view, we know that it's C intersect A union B, and these brackets are 100% necessary because without the brackets it reads differently, divided by the given, which is P of A union B. And I don't know about you guys, but I don't like the look of that formula. I'm looking at that and going, I don't want to write that down. I don't even want you to think for a second that you have to memorize that formula. I'm going to do it from a coloring point of view. I love coloring. I actually chalk colored my back door in a stained glass pattern this week just for fun. A union B is given. So this means everything in A and B is my new world. And effectively, I don't care about any of this stuff out here. I'm not going to mark it up because I want to be able to undo what I'm doing here. But I don't care about any of that stuff. And then what I'm asking for is, what's the probability of C? Well, this number is in C. This number is in C. And this number is in C. And those add up to 0.15. And A union B, we actually looked at earlier, and it was 0.5, I believe. But we can double check. 1, 5, 2, 3, 4, 5. 0.5. So this is a 30% chance. So if I said that A union B was like either you're a smoker or a narcotics user, and then I'm asking for the probability of having a long-term COVID side effect, then the probability, if this data was real, of having a long-term side effect of COVID, given that you are either a narcotics user or a smoker, is 30%. And so that type of question is what we can answer really, really well. I'm going to do one more. I said I would do that one, but I'm just going to undo a bit here because there's one other type of case that I think is worth seeing. And that's the end of my backup. So now I have to paint white. Paint, 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 paint. And I'm going to get rid of this part. I'm going to switch to black. So I'm going to ask, what's the probability of not in A given that you're not in C? Now, this is another example where we would definitely... Oops, I dropped the pen. This is another example where we would definitely hate to see the formulas. So I'm going to use the paint method, not in C. Okay, so how I'm going to do not in C is a little different. I'm going to, like, black out C. You know, I don't care about this part. In fact, I'll get rid of these numbers altogether because we're not going to see this example again. And then I'll come back and paint it. So C is gone, right? I don't care about C at all. I don't even care that that's called C anymore. Kind of looks like a Mickey Mouse. I'm just going to point that out. And so here, what am I looking at now? I'm looking at the probability of A bar divided by the probability of a given. Now, A bar is what's not in A. So what's not in A are these two zones right here. So I can see that not in A has a total of 4, or 0.4. And I can also see that the whole diagram, all of those numbers combined, are 0.55. So this is... we probably could use a calculator here. In fact, I think I have one right here. This is the calculator I really recommend as a DARP shell. It's useful for a lot of features. But read your instruction manual. And on our tea time breaks, don't be shy about asking me for calculator demos, because I'll set up that we can do that. But 0.4 divided by 0.55 is 0.72. And it's actually 0.7272 recurring. So it turns out that there's a 73% chance of being not in A if you're not in C. Okay? 0.4, 0.5, 0.55. Yep. So very good result that we see there. Okay? So this again, chapter 10, conditional probability. We're looking at the basics. You've read the chapter. I'm hoping you're doing some practice questions from the textbook. I'm trying to make sure every week's videos show you the pieces that I feel are most important for you to focus on to get through the assignments, to get through the quizzes, the midterm, and eventually the exam. And I think we'll be back with one more video this week that talks about the mathematical formulas of conditional probability and a side effect called independent. So for now, I'm Dr. McNally, and toodles. I think it's this button.